In this question, we want to determine the symmetric equation of a line passing through 950 and perpendicular to both of these lines. Now these lines are written in symmetric equation form, and the second line has the equation x equals y equals z. But we know we can add this in pen. X is the same as x over 1, y is the same as y over 1, and z is the same as z over 1. And then thinking of the traditional symmetric equation form, we can think of x being the same as x minus 0, y being the same as y minus 0, and z being the same as z minus 0. Which means that this line goes through the point 0, 0, 0 and has the direction vector 1, 1, 1. So to get the direction vector of a line perpendicular to both of those, what we want to do is cross the vectors 4, 2, negative 4, 4, negative 2, 4, and 1, 1, 1. And doing that, we see that we get the direction vector negative 6, 0, 6. Now multiplying through by negative 1/6 gives us a new direction vector of 1, 0, negative 1. And this is like a reduced version of this direction vector. So we see, since we're going through the point 950 and we have a direction vector of 1, 0, negative 1, we see that this is the vector equation of the line in question. And so we can say that x minus 9 over 1 is equal to z minus 0 over negative 1. And you might be wondering, well, what about the y component there? But we have a direction vector component of 0. We can't say y minus 5 over 0 because you cannot have a direction vector, you cannot have a denominator of 0. So what we're forced to do is say y will always equal 5 off to the side. So to recap, we say x minus 9 over 1 equals z minus 0 over negative 1, and y is equal to 5. Now, we want to reduce this a little bit. X minus 9 over 1 is the same as x minus 9. And z minus 0 over negative 1, that numerator is the same as z. And dividing by negative 1 is the same as multiplying by negative 1. It has the same effect. So we can say x minus 9 equals negative z and y equals 5.